I won't skip the step because I'm going to miss something. So I'm just going to write down the terms that haven't cancelled on both sides. Okay, now look at this line for me. Okay, this line here. Not knowing anything else about what this actually means, right? What can I do to make this much, much better? Like straight away. Look at it carefully.
Divide by x, y squared.
Everything factors into y squared, right? Everything. Every single term. Okay? So here's what I'm going to do, and I just want to take note of it, okay? I'm going to divide through everything by y squared. As you'll see later on, y squared, sorry. This is going to be really crucial, okay? So just watch for it. So what you end up with, this time I'm going to divide through and then I'll collect my like terms. You end up with this. Okay? So I divided through by y squared. That's why, for instance, this 6y to the 4 and 9y to the 4 became 6y squared, 9y squared. And that's why 9 minus 6 gives me the 3. Okay, now what?
Divide through by 3.
Divide through by 3. Sorry, that's 2. Now, what's this starting to look like? Right? Now, okay, I divided this through by 3, right? So it's going to be minus 3. I'm going to kick it over to the other side. To see what kind of circle it is, what am I going to do? I'm going to complete the square. So what do I add? What do I add on this side? Halve it, square it. Halve it, square it. You halve that, right? Which becomes 1, and then you square that. So if I add one there, I add one here. Now I can factorize, yeah? So the y squared is just hanging out on its own, and this turns into?
X plus 1 squared.
And the radius is? You're like, for real? After all that? Now here's the thing. Here's the really interesting thing. What is this? Okay, let's come back to our diagram. Okay? And this is a circle.
It's that thing.
I need to go a bit further over.
I know that thing.
It has radius 2, and its center is at minus 1, 0. Minus 1, 0. So that's over here, isn't it? Okay? Now if it's radius 2, the furthest it goes is over to here. See how that's 2 units there? So you're looking like something like this. Sorry, that's terrible, but you get the idea.
Almost as good as Daniel.
Okay, so actually my P is a bit off. It should really be, it's not accurate, right? But P can move anywhere there. Okay? Now, by the way, we're not done. We're not done. The locus is not just...
Just the word P is L.
Well, how old are you again?
6.
Now, the circle is not just enough, right? I missed something. There's something missing. It's not just the circle. You remember, conveniently, I divided through, right? I divided through. Now, think about what that does. If I gave you something else, like say, I don't know, x minus 1 equals 5x, okay? And if you divided through by x in this case, right, you could get a true solution for that. But we lost the solution, namely, x equals 0, right? So in the same way, I've lost the solution here. Namely, y equals 0. Now, y equals 0, what kind of line is that?
Straight.
That's this line, isn't it? Y equals 0 is the x-axis, isn't it? Now, why do we need that line? It's the circle and that straight line. Why is the line important?
Because it's also correct.
Because it also includes it, right? Because if you've got a straight line there, then BPO is just a straight line. So how are you going to bisect it? Well, you just have to be on the line, right? On the line itself, that is. Okay, now here's the thing. I finished that. I was like, really? Really? I was very skeptical. Especially after all of this, I'm like, did I just want it to be nice and neat? So here's what I did. Let's see if I can stay. Is that far enough? We'll see in a second, I suppose. Okay. Let's see what we get. Let's go a bit further. Oh no! I might be a victim of software counterfeiting. That's not nice.
Reinstall Norton antivirus.
Okay, so here's my situation. Let me move this a little bit. Okay, so this is what I drew, basically. Okay, here's my A and my B. There's the moving point, okay, and there's the origin. Okay, now you can see actually that does kind of look legit, right? The red line does kind of look like it bisects the blue angle, doesn't it? It was kind of close. Okay, so to prove it, because this is my circle, right? Let's watch it move, shall we? Okay. Do you buy it? Does it work? Wait for it to get all the way around. Okay.
Wait, does it go around the line? I mean, up and down the line.
Unfortunately, I couldn't get that, but I'm just animating the circle at the moment. But does it look right? Does this angle, do these angles always look equal?
Yeah.
It works, right? So,
That's really frustrating.
Yeah.
All that trouble, you just get a boring circle.
yeah, exactly, right? Now, here's what's left, okay? Here's what I haven't been able to finish. Usually when you go from, here's a geometric rule, and then you get some kind of equation, right? Like that, okay? You get your equation out, and then you look at it and you're like, oh, geometrically, of course it makes sense. Like, for example, when I said, okay, such and such a point, it moves so the distances are always the same between these 2 points, right? And you get the perpendicular bisector. And then you draw it, and you're like, oh, obviously it makes sense, right? You can prove by triangle congruence, if you like, okay? But this thing, I don't know why it works. I don't have an explanation yet. I don't know why. You draw this, if you like. What you know is radius 2, okay? There's my center, okay? So you know there's 1 unit there, 1 unit here, 2 units there, okay? Knowing that amount of information, can you prove or can you show why this angle is always equal to this angle? Okay? I've been sort of scratching my head over it for most of this morning, and I'm really stuck. I can't see any similarity or congruence. I don't know what to work with to show that these angles are equal. I think it has something to do with circle properties, because, you know, it's a circle, so you've got to use that fact somehow. I just don't know how to use it yet. So, sorry again?
Did you ask any of the other?
Yeah, not yet. Oh, well, I still want to let it turn around first.
It's a question.
I don't want to ask other people yet if I can solve it myself, because then the insight might arrive. But I'm going to pose it to you guys to see if you can come up with your own solution, if you can see some insight that I'm missing. Okay? But yeah, I think it's a really interesting question. So there you go.
We're going to get hypnotized. No.
It's not quite going fast enough to hypnotize you. Maybe if I
Faster, yes.
Oh, yes.
Oh,
Oh,
yes.
yes. It's
Oh,
a
yeah.
bug.
How the bicycle was made.
It's a bug.
yeah, that's what it looks like.
It's a piston and a train engine. Never mind. Piston running.
There you go. Okay, so that's it. That's the question. So Victor, I hope you're satisfied.